We're in San Diego for OFC 2018. I'm here with Manish from Source Photonics. Good to see you again.
Great to see you.
Source Photonics is already really well-known key player in the data center market. But what's happening in the market now beyond 100 gig? What's the next step?
Yeah. No, so that's right. We've been for a few years now shipping several 100 gig products, 100 gig LR4 and 100 gig CWDM4 into data centers. And we're very focused on our 400 gig product portfolio.
Okay.
So we are right now demonstrating at OFC a 400 gig QSFP-DD LR8. It's the first small form factor 400 gig product on the market. It'll support a 32 faceplate density as it goes to production in the second half of this year. And beyond that, we're looking at 4-channel 400 gig devices, both the DR4s and the FR4s, that will really support the inside data center applications as we get into the second half of 2019 that we expect to scale in 2020. It transmits 10 kilometer. Our demonstration today actually shows a link between the QSFP-DD LR8 and our CFP8 LR8, which is a little bit bigger module, but they're fully interoperable, over 10 kilometers of fiber. And ultimately, that will be the first step in migrating the aggregation layer of data centers from 100 gig to 400 gig. Over time, that same interface can be used by service providers as they migrate to 400 gig, and then ultimately we'll move into applications such as access. But initially, we expect it to really serve the aggregation upgrades as a huge amount of 100 gig traffic in the front end of the data center needs to converge for transmission across sites or from end to end of a data center.
Okay. The demand in the market is already there, is it, for these products?
Yeah, the cloud providers have not stopped their growth of the requirements and the traffic that's needed. By moving from 100 gig to 400 gig, they're going to be able to, number one, increase their radix for certain applications, reduce latencies. That's going to support new applications such as driverless cars or artificial intelligence. But in addition to that, there's going to be a need for increased density of bandwidth, better space utilization, better power consumption utilization. Migration from 100 gig to 400 gig will really serve that in the coming 2 years.
Okay. Now, another one of the sort of big trends in networking and communications, of course, is 5G.
Right.
Now, Source Photonics already, a long-time player in the fixed broadband access fiber to the home market, et cetera, et cetera. How does that experience and history play into the 5G market? What can you bring to the operators as they start to plan and architect their 5G networks?
Yeah. So the migration to 5G in the access market is expected to be one of the first revolutionary changes in the access market, really in about 10 to 12 years since fiber to the home, PON, really took off. And this is going to drive needs for very high-end components, very high-end 10 gig, 25 gig components with high temperature ratings, with very long link budgets, high output powers. And this is where Source has invested in the past and has continued to invest, and where we can really differentiate against a lot of the other players who have focused their component development really for the data center and the telecommunication markets.
Okay. And so how do those products then fit into the architectures that the operators are looking at for 5G? Because we're basically talking about much more dense fixed access networks to support the front haul, middle haul, and basically support all the small cells that are going to be out there in 5G, is that right?
Right. So first of all, you're going to have real access speeds migrate from 2.5 gig to 10, 25, and 100.
Right.
You'll need much higher performance components supporting those extended temperature ranges, supporting the longer link budgets in order to serve what 5G is driving, which is 10 gigabits to the handset, 10 gigabit to the home. So that's the first place that we'll be able to serve the migration. As we move to the backhaul, you're going to see migrations from 10 gig today, 40 gig today, to 50, 100, 200, 400. Once again, requiring modules that are going to work outside over very wide temperature ranges in a place that we have been able to serve the past and are continuing to develop new technologies to serve the higher temperatures and the higher link budgets.
So there's been talk about 400 gig for a number of years, but it's a reality here at OFC in 2018.
It is a reality. Not only are we showing demonstrations at our booth, we also have demonstrations of the DD module in Tier 1 OEM routing equipment and switching equipment at the Ethernet Alliance booth and at some of our customer booths.
Okay.
So it's actually running traffic, it's showing interoperability with some of our own modules and with one other vendor module, and we're pretty excited that this really demonstrates the first time that their 400 gig ecosystem is very close to ready to serve the market.
Okay, those are excellent proof points. Manish, thanks very much.
Thank you.